AI data center infrastructure need is quite breathtaking, and the estimates of what's needed keep getting revised upwards. So nuclear has a golden opportunity to really address this customer demand in the computation sector that's rapidly evolving. What's really unique about advanced nuclear is that you can co-locate the energy asset with the point of consumption. So it's almost like you eliminate the grid. And AI data center infrastructure is the ideal environment for that, because you've got very high energy density requirements, and you can put these energy assets within the data center environment, and you can locate those energy assets directly coupled to the server rack systems. And in that way, you can have this sort of distributed energy asset, which hasn't really been done before. And so it's difficult for other energy sources to do that. And but you need a very compact system, and you can't get a more energy dense system than a nuclear driven architecture. So that's something that we're really focused on as a company, is to serve that customer need. And we're doing a lot of work with our strategic investors in this space to make sure that our product meets these requirements. So scalability is everything, and we say it all the time to our customers, to our investors, stakeholders. We're not building the company to do a first-of-a-kind demonstrator. We've got to do that. All of the players in this rapidly evolving industry are doing that, of course. But if we don't build the manufacturing system behind the first-of-a-kind, we will never get mass deployments. And so that's something that's really important to us as a company. I believe that we're moving very fast in this area, probably faster than the other companies in the space. And it's really important that we have the factory production model done in parallel with the first-of-a-kind demonstrator. And the factory model needs to be flexible, of course, so we can accommodate changes in the product as we have some lessons learned from the commercial demonstrators. But if we don't do that, then really what we're doing is we're pushing back scale deployments. And we don't want to do that. And the customer doesn't want us to do that. So there's a little financial risk when you go that fast in terms of mass production, but you can decouple that and do that work in parallel. So I think that's one area where AMPERA is a really unique company, because we're really focused on the machine that builds the machine. And that's what's really different with our philosophy. So SMR is just one subset of advanced nuclear. And advanced nuclear was intended to be more modular and more deployable than a, say, Gen 3 architecture, which is traditional nuclear, optimized for power plant production models. And so SMR was really like the sort of first pass on having a more modular distributed solution. The problem with SMR is that you still have a lot of legacy costs, and it's hard to build these systems at the cadence needed by the customer need. So that's really led to this proliferation of advanced nuclear microreactor companies. So AMPERA is one of those companies, but we're very different. We have a different approach. We have the most energy dense system because we use a subcritical architecture. So we have a very compact reactor core. And this is really important metric for us, because we think energy density is the standard by which customers will select systems and technologies in the future. So it's not enough just to have low cost reliability, but you need energy density. And the subcritical architecture gives you the highest energy density because of the simplicity of the design. It's very compact. So we're focused as a company on 3 verticals. Those verticals are computation, AI data center infrastructure. The second vertical is defense. The defense sector need deployable energy assets, transportable energy assets. And the third sector is maritime. And maritime has a tremendously interesting need for this technology, because the applications for maritime extend to very different areas. You've got commercial shipping, cargo shipping container, fleet, for example, is hundreds of vessels globally. And you have cruise line industries very intrigued by this technology. And then, of course, you have the defense aspects of the naval system. So maritime is something that's really important to us as well. And so those are the three verticals. That's where we're going to put our energy to do our initial deployments. But as a company, we want to serve all the customers that have energy needs. And our goal is to revolutionize how energy is produced and consumed for industry, for residential, remote communities, cities, transportation. Decarbonizing transportation is something that we're really excited about. So there's very interesting applications. You can use nuclear energy to do that. So, but you've got to have focus as a company, and you can't just go after every single opportunity. And so we start with those three verticals I mentioned, and then we serve the broader market needs after that. But that's something that's we find incredibly exciting.